So here's the idea. You've got a curve. Maybe this curve is part of a parabola. And right now you've got an average rate of change between the point A and the point B. And what you're looking for is what would it look like right here at point A. So I'll draw at point A, to the best of my abilities, I'm going to draw a tangent line. And currently, my secant line is right there. How do those slopes compare? Are they the same? No. Are they close? Well, they're both positive. They're not too far off. But if I move my point B a little bit closer to A, say there, and I drew a new tangent line, or a new secant line, sorry, can you see that the slopes are closer than they were before? And if I move that point B even closer, right there, now my secant line is getting closer to my tangent. And if I would keep doing that, moving it closer and closer, here, wow, well, that's probably poorly drawn. It should still be a little bit bigger. But the slope is even closer. And if we could get it really, really, really close, the slope of the secant and the slope of the tangent would be the same. Does that make sense? That the closer you put your 2 points together, the closer it's going to be to the slope of the tangent. And this idea of getting closer and closer and closer to something is what we've been studying so far, right? That's limits. So if we could somehow take the limit as it gets closer and closer and closer, then maybe we'll be able to figure out exactly what the tangent of that red line would be. So we start off with our idea. What's the slope of our secant? It's just going to be our rise over our run. And if we have one point at x f of x and the other one at a f of a, this length will just be x minus a. That'll be our run. And this height will just be whatever the difference in our y values would be, which would be f of x minus f of a. So here we have the slope of our secant line. Now, if we want to get the slope of our tangent line, as x gets closer and closer to A, which we saw by moving that point B closer and closer, then this limit will get closer and closer to the slope of our tangent. And if we can evaluate this, then we're going to figure out exactly what our tangent slope is. So let's just do a preliminary example. Notice I labeled this, if you like highlighting things, I like highlighting things. We're going to learn two different formulas, and this is the first one. So let's say we take a parabola, and you want to find out right here at 2, 4, how steep is that line? Well, first of all, I hope you can see that it has a positive slope. So we should get a positive slope for that red line. But what we're going to figure out is we can figure out that slope by taking the limit, and we're really interested as x gets close to what value? To 2. So as we put another point on here, and as we make our secant line get closer and closer and closer, then the slope between the green dot and the red dot will be basically the same as the slope of our tangent. Now, our function that we're dealing with right here is a parabola. So f of x, in our case, will be x squared. Now we're figuring out our a value is just 2. What happens when I plug in 2? 2 squared is 4. And we're going to divide by x minus, and since we're trying to figure out when it gets close to 2, it'll be x minus 2. Now, if this was the easiest limit possible, we could just plug in 2 and figure out what it would be. But unfortunately, we get 0 divided by 0. So any strategies for determining this limit? Factor out the top. It's a difference of squares. And how does that help us? Yeah, we can cancel those out. And once you cancel those out, you're no longer dividing by 0. So now you can plug in 2, and we get this limit's equal to 4. And so the slope of that red line at 2, 4, you could go over 1 and up 4, and that would be the slope of that line. I had an applet that needs an update to Java that is really nice for just dragging points closer and closer so that you can see that the secant gets closer and closer to the tangent. But I think what we drew on the board was easy to see that as well. So here's our first question. We've got a different parabola, 3x squared plus 6x plus 1. We want to find the slope of that tangent. And we're also going to review some stuff from grade 10, how we find the equation of that tangent line as well once we've found out the slope. So first of all, using our first formula, our slope will equal the limit as x gets close to, and what value are we trying to find this time? We're trying to find as x gets close to 2, because we're looking for the value at 2, 1. And on the top of our fraction, it will be f of x. So that's just 3x squared minus 6x plus 1 minus f of 2. If you plug 2 in, you're going to get 3 times 4 squared. Maybe I'll just show it here. 3 times 2 squared minus 6 times 2 plus 1. Put it in brackets because we're subtracting all of it. So we need to make sure we figure out that value first. And don't just subtract the first term. And on the bottom, we're going to have x minus 2. So it always starts off with these limits that you're finding the slope of a tangent that you have a problem, because if you plug in 2, you would divide by 0. But what's nice about them is if we simplify the top, we're going to get 3x squared minus 6x plus 1. And when we evaluate this whole thing, it's going to be 12 minus 12 plus 1, another 1 there, all over x minus 2. So the 1's cancel out. And on the top, we're just left with 3x squared minus 6x. On the bottom, we have x minus 2. Any ideas? We have to factor first before we cancel, because right now this minus sign means all of this is grouped together. And the only way you can simplify a fraction is if a factor is identical in the numerator and the denominator. And right now the 3x squared minus 6x isn't identical with the x minus 2 on the bottom. But if we factor out a 3x, whoops, I forgot my limit. Limit as x goes to 2. So we have to write that limit every single time until we evaluate it. And now that we've factored out the 3x and simplified the x minus 2, we can evaluate. So our slope is going to equal 6. Now we have our slope. And we have our point. How do we find our equation of our line? Well, I'll give you two different ways, sort of a review of two different methods you might have used in grade 10. How many people are familiar with y equals mx plus b? Okay. You almost think it's common sense now, but way back in grade 10 you'd never heard of it before in your life. Okay, y equals mx plus b, if you want to use this as a way to solve it, because you know a slope and a point, that's all you need to find an equation of a line, you can plug in the point y is 1 when x is 2. The slope you know is 6. The only thing you don't know is b. And subtracting 12 on both sides, you figure out that b is equal to negative 11. So now you know the equation is going to be y equals 6x minus 11. Or perhaps you like to use the point-slope form of a line, which looked like this. Y minus y1 equals mx minus x1. This form of the line isn't as intuitive as y equals mx plus b. People don't remember it as well. But it also is easy to figure out the equation of a line because you just plug in your point. Y minus 1 equals 6x minus 2. You distribute the 6, add the 1 on both sides, you get the exact same equation. So you can use either one. Just something I want to point out. When we plugged in everything earlier, limit as x goes to 2, it was this is f of x minus f of a, and in this case our f of a was when a was equal to 2, because that's when we wanted to find it out. Now, when we plugged it in, f of x was easy because that was given to us, and we actually calculated and plugged in 2 to calculate what y would be. Can you see where in the question that was given to us that we wouldn't have had to do that? The point, right? When it's given the point, that's our y value. That's the same as f of 2. So we wouldn't have had to plug it in to calculate it. Not that it's bad to do that little bit of mental math, but it's not surprising that we got 1 as the value for that. Right? We did a little extra work that we didn't have to. We would have known in this question that that was given to us. So just some things to observe after, because sometimes you do something and then afterwards you go, oh, I guess I wouldn't have had to do that extra bit of work. But some questions won't give you the point. They'll just say, find the slope of the tangent when x is equal to 2. Then you would have to plug it in to figure out what f of 2 was at that time. So this is Formula 1, how to find the slope of a tangent and how to find the equation that way. I'd like you to do this next example on your own. So we plug it into the formula, look at the slope, f of x minus f of a over x minus a. And as we simplify it, and factor it, the limit becomes 4. So we know that our value of our slope is 4, and we have a point at 1, 3. How'd you guys do with getting a slope of 4? Good? Now getting into the equation, again, here are both of the different forms. Pick the one you like best, either y equals mx plus b or the point slope form. And both ways you'll get an equation of 4x minus 1.